You can go from any one point here by a fractional integral up here. And so there's a fractional integral of order a half that's better than what was needed to do the Bieberbach conjecture. And when I was called by Gauci, and I called him back after he told me what it was, not in this form, but in a different form. And Gasper and I had done that 10 years earlier. I said, that can't possibly prove the Bieberbach conjecture, because the Bieberbach conjecture is sharp, and this is a whole fractional integral of order a half weaker than things that we know are true. Well, I was wrong. The Bieberbach conjecture is sharp of its type, but there's a different type that's even sharper, and this stuff proves that.
And the real reason you didn't believe that the branch proved it, because the branch had a reputation for
No.
never proving it.
No, that was not the real reason. I had mathematical reasons. That was other people's reasons. I had mathematical reasons why, but I was wrong. And don't trust experts when they tell you that something can't be done. All they're saying is that they don't know how to do it. But if somebody who's worked hard in an area for a long time and knows a fair amount says there's probably something there, listen to them very carefully. And so the first question that I thought would never be solved was to do the analog of this sharp result by Szego up here. And for alpha equals beta, that was done by Gavin Brown's Stomatos Commandus, maybe Long, I don't remember who was involved in it. And there are all sorts of results like that that are very sharp. I had no idea that anybody would ever have the tools to do that. There's a nice result that's waiting to be proven here. If you change that to a beta, but take the zeros of J alpha, for beta equals minus a half, it was known. And it was known along here, but Urban Mackay used his Stern comparison theorem to show that it's going to be true with this as the value for alpha. So there's a beta of alpha. And so it's the value of beta for which this thing is going to be 0. And down to minus a half. And somebody can have somebody
minus 9 minutes left. Hurry up.
Somebody at the Mathematics Research Center years ago used a program that Carl de Boer wrote for doing numerical integration to get data for what happens at 1/10 intervals between minus a half and a half. And the numbers are clearly decreasing. We don't know how to prove that. And the curve is also clearly convex. We don't know how to prove that. And that's a nice problem, because none of the tools that we have seem to, we don't know how to do it. So it's going to require some new ideas. And let me take one more minute. I've got one more minute. I've got going until 12:15 or 12.
What time is up?
Oh, my apologies. What I was going to say is, well, there are some generating functions that are simple rational type functions where we know things have the positive power series coefficients. So they're absolutely monotonic functions. And we know a number of interesting examples of that, and nobody has moved in and tried to do anything with questions that I raised in a paper of trying to find other sets where we know extreme points in a certain convex set. And so there is a paper of mine in some proceedings that's buried somewhere that has some problems that nobody has looked at. And that's what I thought people would do. Now that we had computer algebra systems, they could then do a lot of this stuff easily.
Okay,
And
well,
all
I
they've done is all the deeper stuff that I never thought I would live to see. So, my apologies.
I want to make a quick comment.
Yes.
The Askey inequality was an amazing application and a compliment to Hadamard's principle. Hadamard said the shortest distance of a real result is via a complex. In this case, the shortest result in a complex analysis was via the real analysis. That was amazing.
And I will owe you an apology for speaking over time. I heard Ed Hewitt give a talk when I was an undergraduate. He started by saying there are two cardinal sins of a eloquent speaker. One is to state and or prove a false theorem, and the other one is to speak over time. Now, stating or proving a false theorem is a minor sin. But there have been some very interesting things that have come from false proofs or false results. Speaking over time may be a minor sin, but there is another major sin, and that's not to tell anybody why anybody cares about what you're talking about. And so far, nobody's sinned that direction. I hope nobody will.
So lunch is up on the 4th floor.